The last thing we want to look at in this chapter is a few sort of ideas, terms that are useful to us. The first of these is intensive properties. So over on the right I have a picture, and this is wood floating in water, and then we also have a ring. I don't know if you can see that well, but that's a ring down there which is sinking. But the way that I actually want to talk about this is more in terms of this word intensive. So just imagine this situation. What if we had a smaller piece of wood instead of this size piece of wood? Would it still float? And hopefully you realize that the answer is yes, because it has the same density whether it's a large piece or a small piece. So we have a special name for those types of properties. Properties that don't depend on the amount are referred to as intensive. So don't depend on the amount. Don't depend on the amount. And then we also have other properties that we know do depend on the amount. Some of this is kind of obvious. So if I have a balance and I'm weighing a piece of wood, well, obviously a bigger piece of wood is going to weigh more than a smaller piece of wood. So properties that depend on the amount are referred to as extensive. And we'll come back to those words quite a few times during the course, so just hang on to that idea right now. We also want to talk about chemical properties and physical properties. You may think because it's chemistry that we're only interested in chemical properties, but chemistry we're actually also interested in physical properties. So first of all, let's talk a little bit about chemical properties. So I have a picture here of some wood burning, and we could say that a chemical property of wood is that it burns. And over here I have a piece of iron that is rusting, and iron rusting, which really means iron reacting with oxygen, is also a chemical property. So chemical properties really are almost entirely how something reacts, the way that it reacts. Okay, at the bottom I have a picture of a bunch of gold from Fort Knox, and we can say that gold is shiny, that it would conduct electricity, that you could take a hammer and you could beat gold into a thin sheet. That's called being malleable. You can pull gold apart and make it into a wire. That's called ductile. So physical properties are kind of what you would expect. They have to do with the hardness, the appearance of something. And chemical properties, again, are how something reacts. So closely related to chemical and physical properties are chemical and physical changes. So this is there is a slight difference. So a chemical change is something where you have a different product than what you started out with. In other words, you've combined elements, you've broken apart molecules, you've had some reaction so that you don't have the same substances that you had to begin with. And there's no simple way to get back. For example, if I have rust, I can't easily make rust back into iron. I mean, it could be done, but not in any kind of simple way. Likewise with wood, you are, I'm sure, aware that you can't take ashes and make them back into wood. So the chemical changes tend to be more one-way reactions. This is representing up here, this is methane burning. And likewise, once you've burned methane, you still have the same atoms, which is something we'll talk about more in the future, but they're rearranged in such a way that you can't easily reverse them. On the other hand, if we chop some wood, well, we have wood to begin with and we have wood at the end, so that's really not any kind of chemical change. It's still the same substance. And over here, this is molten iron. So if we melt iron, it's certainly different. It's much hotter in the molten form, but we can cool it off and go right back to the solid form. So things like heating something but without it changing chemically. And sometimes heating and burning are easy to confuse. So burning is kind of an extreme form of heating. When you burn something, you actually change the composition. You can heat something and you are just changing its physical state. So for example, if you have water and you boil it, then you have water vapor, but you can condense that vapor and go right back to water. You haven't changed water into something fundamentally different. Let's see, this one down here, this is sugar dissolving. So let's apply this same kind of idea. So could we get the sugar back once it's dissolved in water? Well, the answer is yes. We can just evaporate the water and we're back with sugar. So dissolving, kind of has the appearance of being a chemical change, but if you apply the idea that you can get it back by some simple physical means, then that's going to be a physical change. Then also down here a little bit lower, let's see what else I've got here. So here we have, let's see, for this one, this is silver, tarnishing. So all these words like tarnishing, fermenting, rusting, burning, all of those words really indicate a chemical change. And I don't think this is probably obvious. Actually, when I was looking at it, I forgot what it was, but these are grapes fermenting. So grapes fermenting obviously are changing into alcohol, and it's like a sugar changing to alcohol and water. So that's going to be a chemical change also. So we'll do some labs and take a look at this in more detail. And obviously this is really the sort of prime idea in the class, is this idea of chemical changes and physical changes.